Welcome you students. Here I come up with another question from projection of straight line. A straight line AB 85 mm long has one end 15 mm in front of VP and 10 mm above HP, while the other end is 50 mm in front of VP and 45 mm above HP. Draw the plan elevation of the line and determine the inclination of the VP and HP. First of all, take all the information maximum from the question. So take the given data. A straight line AB 85 mm, that means it's a true length of the line. Capital AB 85 mm, and then one end in the sense the line is AB, so I'm going to take this end as A. The A end is 15 mm in front, 15 mm in front of VP and 10 mm above HP, 10 mm above HP. What about the other end? Is 50 mm in front of VP. Is 50 mm in front of VP and 45 mm above HP, right? So these are the things given in the questions and all the unknown things we have to find it. Always remember, whenever you are solving any problems or whenever you are working the projection of straight line, minimum we need 5 data. Check here, 1, 2, 3, 4, 5. We have 5 data. So this is more than enough to conclude the profile, right? Okay. So first of all, start drawing a reference line. Reference line which is X, Y, right? Above the reference height VP and below the reference is HP. Always you have to start with the locus. If you find all the 4 locus, your projection will be very easy. So just go with the locus first. So what about the locus of A? 15 mm in front. Am I right? 15 mm in front in the sense as far as the first angle concerns, where it capture below, right? So take from the XY, measure 15 mm by having points from the both end by keeping your scale right angle to the reference line. Take the measurement and go for a line passing through the picked point, something like this. So this is the locus of A. Since it is a top view, I captured with the A. Then 10 mm above HP, above in the sense it's captured above the reference line. So measure 10 mm by keeping your scale 90 degree to the reference line. Take a point on both sides and go for a horizontal line passing through it. So this is the locus of A dash. It's in the front view. So take A dash, right? So now the locus of A is specified in the front view as well in the top view. So we can specify the point, okay? So take one end, it's a one end, am I right? So in the left extreme, I'm going to prefer my A dash. So if you draw a projector line like this, projector, it's a 90 degree line or vertical line and intersect with the locus of A, you could able to find the projection of A in the top view, right? So now one end is specified in the locus. Then move to the next end, B. What about the case? 50 mm in front of VP. It's going to capture below the XY line in front of VP. So take below reference line with a measurement 50 mm, having the points on both sides, go for a line passing through it. So this is locus of B. And what about the next 45 mm above HP? So measure something like this. It's going to capture above the reference line. So measure it and go for a line just 45 mm above HP. So this is our locus of B dash. What is next? We have taken A locus and B locus. What is remaining? A true length. So now just measure this 85 mm in your compass. In order to find the other ends, what we are going to do is, by placing A dash as center, we are going to find the next end, that means B dash and B. So just in the locus of B dash, by placing A dash as center, have a cut mark. Okay, measure 85 mm and keep it A dash, you are going to find the B. So in the B locus, go for a cut mark. This is the point B1 dash. This is not the final end. Okay, so I have captured as B1 dash. Take a line. This is your true length in the front view. So if you drop a line, if you take a projector line to the locus of A, it intersects and that point becomes B1, and you could see the line A to B1, which is nothing but top view length. Top view length. The same thing, measuring 85 mm in your compass and placing at A by having the cut mark in the locus of B, you could get B2 and the true inclination in the top view. Okay, or true length we can get in the top view. If you take the projector line by extending to the locus of A dash from B2, it becomes B2 dash, and you could able to see the line front view length, which is A dash to B2 dash. So now we have the top view length and front view length. So easy. Now we can just work out the change in position of line method. Here this is our this is our top view length. So by just changing the position to the locus of B, we get the final front top view, and by taking this measurement and changing the position to the locus of B dash, we get the final front view, right? So take your compass and measure A to B1 distance, that means top view length distance, and keeping A as center, go for an arc to the locus of B. It cuts, this is your B. If you connect a line A to B, it is your final top view. So go for a dark line. This is your final top view. Go for a dark line. So the line flow is coming like this. From the front view, extended and rotated, and you could get the dark line, which is final top view, right? The same thing you have to follow in the front view length. Just measure A dash to B2 dash and just keep A dash as center and go for an arc in the locus of B, okay, in the locus of B, so that get the arc like this, and you will get the intersection. So this is B dash. This is the final front view, so make it as B dash. If you connect a line B dash to A, this becomes your final front view. So make it as a dark line. And see, if you connect a line B dash to B, it will be a straight line. If you want to check whether your projection work is right, you can check from the end projector lines. That means the A dash to A line will be perpendicular line, and if you see the B dash to B, it will be a perpendicular line. These are the end projector, so that you can conclude the drawn profile is a right tone. Okay, fine. So as far as this diagram concerned, in the straight line, final front view and final top view should be a dark one, and next we have to show all the data about the profile. So here, this is the true inclination in the front view, theta, and this is the true inclination in the top view. We can make it as pi, and this is the angle, apparent angle in the front view, or else final front view inclination, which can be denoted as alpha, and here it is apparent angle in the top view, which can be denoted as beta. Okay, at last you must make a tabulation or box like this, and you have to make all the data regarding the true length of the line given in the question 85 mm. Same manner, have to take the theta measurements, pi, alpha, then beta. Okay, so theta measurement, by keeping your protractor as this manner, you can read the theta, right? So you will get in the degree, and the same manner if you keep your protractor as this manner, so that you could able to read the pi, it as well get in the degree. The same manner the alpha angle also, by keeping the position of your protractor like this manner, you can read the angle, which can be taken in the theta degree, and as well beta from the top view you could able to read it. And also final front view length should be measured, that means A to A dash to B dash and A to B, you should measure it. So this is the final front view length. With the help of scale, measure it and take the value you get in the mm. The same manner from the final top view, you can take the measurement with the help of scale and read it in the mm. Okay, so we have displayed, and in the diagram we must capture the dimension as well as we have to capture the note, right? So here all the measurement about the true length, then locus of the A and B is given, it should be captured. So see here 15 mm in front of VP, so it can be captured here. So for that I am taking a vertical line like this, and this is the exact portion we have to mark about the locus of B, 15 mm. So here above the line I am going to write 15, right, and 10 mm above, right. So here is the spot. So here I am going to take the line, dimension line with filled arrows, and going to write above 10. What is next? About B locus. So for which take the line something like this. Take the line. So from here to here we have the measurement, and from the here to here we have the measurement. So in front of VP 50 mm, so capture 50 mm above the line like this, and 45 mm, right. So like this you have to capture it above the line, right. One more thing, true length. So true length in the sense A dash to B1 dash, otherwise A to B2. So here in the front view I am going to capture, for that take a perpendicular line. If you are capturing, take a perpendicular line to the A dash to B1 dash line, right, and just go for a parallel line, which is a dimension line, should be parallel to it, and right above the line 85 mm, sorry 85, you should not write it mm, right, 85, And what is next? As node, right? All the dimension we have marked in mm, it should be captured in the what? Gate line. So the bottom of the right extreme, I am going to make a gate line and write all dimensions or in mm okay. So just we have drawn the measurement as it is given in the question. So also we can write about the scale. Since we have used the true scale, we can write the scale as 1:1. Okay. I hope you understood. Thank you so much.